Welcome guys and gals. This is your host Frog Prince Rana, and thank you for dropping by. This is not a debunk video. I'm hoping to experience the wonders of North Star with you, and if someone just happens to be wandering into the fascinating and crazy land of flat Earth, this should be a good sanity check for them. Like most normal people. Okay, fine. Most normal people do not get into debate with people living in fantasy lands. It is us. And I believe we are called globers or trolls. Quite often we are asked for proof of a spherical world. Knowing how much flat earther detest latest technology, if the proof has any connection to recent tech, somehow it would jump to NASA to Walt Disney. It is 6 degrees of separation with a buckshot. Finally, everything would be declared CGI or composite. Thus, I like to refer to those old observations that people have used to figure out the shape of our planet. My top 2 points are lunar eclipse and Polaris. My last video, Flat Earth Breaks Moon, I did get to talk about lunar cycle, lunar phases, lunar eclipse, and how we can use the shadow of Earth to even calculate the diameter of Moon and the distance. This video is about my second favorite, Polaris. I will discuss their common talking points later, but first, the wonder. The North Star. Why is it called as such? Because we use it to find north. Wait a minute. We're orbiting around the Sun, which itself is one of the billion stars in our galaxy. Our galaxy is one of the billions in the universe, all moving in their own orbit. With all that going on, how is it possible for a star to appear steady forever? Well, yes, it does not stay steady forever. Our current North Star is Polaris. But 5,000 years ago, when the pyramids of Giza were being built, it was Thuban that was the pole star. Meanwhile, our modern Polaris, which many centuries ago was an ordinary star known by the name Phoenice, won't match Thuban's precision when it most closely aligns with the North Celestial Pole on March 24, 2100. Polaris will be 27 minutes 9 seconds from the North Celestial Pole at that time. The Northern Hemisphere also has had long stretches without a pole star. After the reign of Thuban, but before that of Polaris, Kochab in the Little Dipper served as a rather poor pole star in 1100 BC. Looking into the future, Errai will become the northern star around 4000 AD, and Alderamin will take its turn around 7500 AD. So in the meantime, we have Polaris to gaze upon. Now the beauty you observe with Polaris, and I did say observe, any one of us can do it. Let me explain. On the North Pole, Polaris is almost overhead. Well, it is actually 0.7 degree off from celestial north. So we can see it making a little circle around that exact point of the North Pole every day. When we move towards equator, we observe that not only Polaris appears lower down towards the horizon, but also that angle correlates to our actual position on Earth. Meaning, when we are on North Pole at latitude of 90 degree north, Polaris is overhead, and the angle it makes with the tangent line or horizon is 90 degree. If we move to any position on latitude of 80 degree north, well, Polaris is making an 80 degree angle with tangent line. We observe the same thing all the way to equator, where it is at horizon line or close to 0 degree. We move to the other hemisphere, and we cannot see Polaris at all. This is all real observations. Now let's talk about distance. If we look at Polaris from a little town in UK called Petersfield, it would appear at 51 degree. If we head north, around 333.795 km away, we have Upper Helmsley. That is quite close to me. From here, Polaris is at 54 degree. Two things to keep in mind. In my example, I have used the same longitude of 0.943194 degree west, and the distance is point to point and not route distance. As long as we follow those two things, we can use any location within Northern Hemisphere to test this out. The angle and distance throughout our observation appears linear. Well, let me show you. This place is near Thornborough at 52 north. Polaris appears at 52 degree. I said it is linear scale. So, if 3 degrees of Polaris angle occurs at 333.795 km away, 1 degree of change would occur at 111.265 km away. On Google Earth, that route distance shows us as 111.258 kilometers. So we have a discrepancy of only 7 meters over hundreds of kilometers. That is pretty good. Time for a short detour before moving on to what does this all indicates. How do we find Polaris? Well, we can use modern technology to show us where it is, or we can use the ancient method of following the stars. Polaris is located in the constellations of Ursa Minor, the Little Bear, also known as the Little Dipper. Polaris, the North Star, lies at the end of the handle of the Little Dipper, whose stars are rather faint. Its 4 faintest stars can be blotted out with very little moonlight or street lighting. The best way to find your way to Polaris is to use the so-called pointer stars in the bowl of the Big Dipper, Dubhe and Merak. Just draw a line between these two stars and extend it about 5 times, and you will eventually arrive in the vicinity of Polaris. And always keep that fact in mind. Polaris is more accurate than any compass. A compass is subject to periodic variations and can only show you the direction of the lines of the strongest magnetic force for a particular spot and for a particular time. Okay, we are back. Let's try our observation on a flat Earth. To start with, if North Star is very, very, very far away, the rays would be perpendicular to a flat plane. So regardless where the observer is, it would always be overhead. As that is not what we observe, yes, I'm using that word a lot, because flat earthers seems to hold observation with a high esteem. The only other alternative then becomes Polaris is not as far as what we are being told. Fair enough. Let's bring Polaris closer and see what happens. As you can see on screen, yes, it seems to be showing how Polaris can appear at different angle on a flat plane. Trust me, we will move to 3D view. But even on this 2D view, there are some issues. Let's move towards equator. This is where Polaris appears to be near horizon to an observer. Okay. Now let's compare what these two observers are observing. Do you see the angle top and bottom of Polaris makes to an observer? That is angular distance. As the observer near the equator is farther away from Polaris, that angular distance is much lower than the person near the pole, and thus near equator, Polaris would appear to be much smaller. Well, that does not happen. Polaris appears to be same size to all observer. Just to qualify that sentence, I'm talking about in similar environment and lighting condition. Moving to 3D view, things fall apart even faster, which gives us a true idea of the scale of craziness this model is offering. Though I might sound like a Northern Hemispheric chauvinist, as I didn't mention anything about Southern Cross. Well, it is like Polaris for those people, but just not as good. as it can be seen from Northern Hemisphere. That was a joke, people, about being not as good. So here is the final model. These people with blue arrows can see Polaris, those with red arrow can see Southern Cross, and because the cross is not as cool, from places like Key West, Florida, you can actually see both. We can try out different shapes. One of my favorite YouTuber Baldy Cats have a video showing how various shapes behave with Polaris. If I can find the link, I will add it in description. In summary, a square or rectangle has the same issue as a flat plane. A shape like triangle? Well, Polaris is far away. Every observer in the declination would observe North Star at the same angle. If it was closer, same issue as flat, but much worse, as the triangle itself causes a bigger angle headache. Hexagon is couple of triangles. We have flat issue at the edge and angle issue at the side. Diamond is two triangles, and oval fits a bit better, but it is not linear when it comes to what we had observed. Finally, let's look at our reality. What happens with a spherical shape? Well, if the angle to distance was linear, and 1 degree gave us 111.265 km, what would 360 degree or the circumference be? Well, 111.265 times 360 is 40,055.4 km. Measured around the poles, the circumference of Earth is 40,007.863 km, and around the equator, it is 40,075.017 km. Hopefully, any budding flat earther would be able to appreciate these facts. Now, the comebacks I usually get from flat earthers. Polaris is not visible in the Southern Hemisphere due to the low ceilings of the stars and angular limits along with atmospheric disturbance. Full disclosure, I was not sure what it meant, especially the low ceilings of the stars. So James Bond 78 clarifies it further with, the angle of Polaris changes depending on your location due to the angular resolution. Look into angular resolution and perspective, and you will see how objects disappear bottom up even on the flattest surface you can find. Arrgh! If I could have one of them face to face, then maybe using my mentalist ability, I would be able to tell if these people actually believes what they are saying or they're just saying, having a big laugh. I mean, in this comeback, our James Bond 78 talks about angular resolution. Well, it is a real thing, and it describes the ability of any image-forming device, such as an optical or radio telescope, a microscope, a camera, or an eye, to distinguish small details of an object, thereby making a major determinant of image resolution. Is that not the most blatant non sequitur ever? What does that have to do with the angle it makes with the tangent? Fine, maybe tangent was a big word. In geometry, the tangent line, or simply tangent, to a plane curve at a given point is the straight line that just touches the curve at that point. We're talking about the angle on the top image, where angular resolution relates to the angle on the bottom image. It is two different things altogether. If angular resolution, which is the smallest angle between close objects that can be seen clearly to be separated by an optics, is the reason people in Southern Hemisphere cannot see Polaris, well then to people near equator, Polaris would also appear smaller than those up north. Just saying. So flat earthers, you guys like your observations? Well, there were loads. Put it in the pipe and smoke it. Quick plug. I do have several videos showing what angular distance and resolution does. Also an experiment showing objects do not disappear from the bottom on a flat plane. Here is where I'll end this video. Thank you for watching and sticking till the end. If you have enjoyed this content, Well, like, comment, share and search. Most of my videos are debunking bad science. So if you're into those, you may want to check my channel out. If you can also subscribe if you haven't already. That would definitely help my little channel grow. It doesn't cost you anything. Thank you once again. Wherever you are, have a safe day. Signing off.